Okay, welcome back, and today we're going to talk about a theorem. This is a theorem that deals with complex numbers, and it's called de Moivre's theorem. And what this theorem says is if n is a positive integer and z is a complex number in this form, trigonometric form, then z to the nth power is written like this: r to the nth power times, again, the sum here, which is cosine n theta plus I sine n theta. So we raise r to the nth power and we multiply the angle by n. And so now, where does this come from? Well, it actually comes directly from what we talked about last time, looking at a product of complex numbers. So we know that z times z is going to give us the sum, right? We're going to use the sum of the angles here, right? So we're going to get theta plus theta for both of these, and we're going to get r times r, or r squared. So we're going to get r squared cosine 2 theta plus I sine 2 theta, right? Just using the product formula. So if we keep doing, then if we do z to the third power, well, that's z squared times z, right? And so if we keep doing the product formula over and over again, we end up coming up with this formula, which is de Moivre's theorem. Okay? So it's easy to show. Okay? Now, let's do an example of how we would use this. Okay, so let's do this example of applying de Moivre's theorem. And so let's have 3 plus 3i to the fourth. Well, it's in standard form. So the first thing we want to do is we want to write it in trigonometric form. Okay? So let's do that. So if we write it in trigonometric form, well, again, this is a and b. So again, our r is going to be the square root of what? A squared plus b squared, which is going to be 3 squared plus 3 squared, times cosine, now theta. What's theta? Now remember, we're going to take the tangent of b over a. So tangent theta equals b over a, which is equal to 3 over 3, which is equal to 1. So the tangent of what angle equals 1? Well, we know that's a 45-degree angle, right? So, and that's going to give us pi over 4. So the reference angle is going to be pi over 4. That's going to give us, not pi over that, plus I sine pi over 4. Okay, so now, okay, so if we simplify this, we get the square root of 18 one last thing. Square root 18 I sine pi over 4, and of course this is all raised to the fourth power. So now if I simplify this, what am I going to get? This is going to become 3 root 2 times cosine pi over 4 plus I sine pi over 4, and this is raised to the fourth power. Now we're going to use de Moivre's theorem. And so what do? We raise this to the fourth power. So this is going to be what? It's going to be 3 root 2 raised to the fourth power times cosine, let me do it a little differently, cosine of 4 times pi over 4 plus I sine 4 times pi over 4. And that's it. So now we just have to simplify this. Okay, so this is going to be, hold on. So we're going to use the property of exponents here. And this is going to give us 81 times 4, right? Yeah, 81 times 4, so 4 times 80 is 320, and then 324, right? That's right, yeah, 324. And then this is just going to be what? This is going to be cosine of pi. I sine pi. Oh, that's nice. Well, cosine pi is 1, sine pi is 0. So this is nice. So we just get 324. Okay, now it depends on what the direction you're given. Okay, you may not have to need to convert the answer to standard form as we did. Okay? But this was nice and easy. 324. Okay. Have a great day.